Good morning there, folks. Morgan here. This is a video intended for March 17th, 2020. Happy St. Patrick's Day. And this is going to be our first video of the day where we go over a bunch of the homework from March 16th. And the assignment was the conjugate acid-base pairs. So we start off here with the question, what is the difference between an acid and a base? And there are a lot of different ways that we can be answering this. We can say that an acid is a proton donor and a base is a proton acceptor. We can say that an acid contains H plus and that a base contains OH minus. So there's more than one correct answer there. Let's not worry about that. So what are the 6 strong acids? They are Hickel, Hibber, and Hi, the friendly acid, HCl, HBr, HI, and H2SO4, HClO4, and HNO3. And that is a list that you'll probably have committed to memory pretty quickly. So the next question, identify the following as either an acid or a base. What we typically do is look for formulas that start with hydrogen, and those are our acids like HCl, HBr, HI, HF. I wouldn't count either of those because they contain hydroxides. This is an acid, this is an acid, again hydroxide. H3N is the acid version of this, where NH3 is the base version. H2S is an acid, and all the rest there are bases. Okay, in question 4, we are completing some reactions, and what you have hopefully realized is that these all represent acids, hence I put the word acid there, and they're all going to start off with H3O pluses. And the conjugates here will be Cl minus, F minus, C2H3O2 minus, HCO3 minus, and H2PO4 minus. Now, in question 5, these are base dissociations, and each one of these produces an OH minus. Now, they're going to donate, the waters are going to donate a hydrogen to the bases. So that gives us NH4 plus, HF, NH3, CH3, NH2, and HClO4. Okay? All right, so you should be able to write those. We're going to be doing a lot with them. Okay? And that'll take us on to our next idea, which is looking at conjugate acid-base pairs. So the difference, jokingly here, between an acid and its conjugate base is 1 hydrogen atom. So yes, that is a conjugate pair. No, that's not, and yes, that is. The difference here is simply 1 hydrogen. In the acid, it has it. In the Cl minus, it does not. Here, this lost 1 hydrogen to become HCO3 minus, and this is a no, because that has lost 2 hydrogens. No, yes, no, yes. And that fools a lot of people because you're gaining the hydrogen rather than losing it, but that's fine. No, and yes. All right, so going over to the back here, the conjugate of HCl would be Cl minus. The conjugate of HBr would be Br minus. The conjugate of HF would be F minus. Then for acetic acid, it's acetate ion. And here it's NH3. So the conjugate base is 1 hydrogen less than the formula here, and 1 step more negative. So the Cl becomes Cl minus, the Br becomes Br minus. The NH4 plus, however, becomes NH3, and it's not charged because that's one step more negative. All right, in number 8, ammonia has a conjugate acid of ammonium ion. Then we have HI, HCO3 minus, NH3, and H2SO4. All right, now, number 9 gets a little more complicated. We need to know what our strong species are and what our weak species are. So let's imagine we have a strong acid, HCl, and it reacts with water, and it forms H3O plus and Cl minus. We know that HCl is a strong acid. It's really good at donating hydrogens, which means Cl minus must be a very weak conjugate base. Now, the point here is that if HCl is great at giving off hydrogens, even if Cl minus picked up a hydrogen, it would end up donating it. It would fall right off of it. So it's not a very good base because bases are what pick up hydrogens. Since HBr is a strong acid, its conjugate would be weak. Since HF is a weak acid, its conjugate would be strong. Acetic will have a conjugate acetate, which is strong. NH2 plus will have NH3, and H2SO4 will have one that is H2SO4, which is strong, and the NH3 is weak. Okay, now, one of the people that taught me this material always emphasized that we should not use definite descriptions like the word weak or the word strong, and that we should actually call weaker or stronger. And that's actually a pretty good idea. So these are relative to each other. Okay. Now, the most important question probably here is finding the conjugate pairs. HCl reacts with H2O and gives us H3O plus and Cl minus. And like we were talking about in yesterday's lecture, these would be the conjugates. This is the acid, so this is the conjugate base. Acid reacts with base, which makes this conjugate acid. NH3 will react with H2O, and that's going to give us NH4 plus and OH minus. Here's a conjugate pair. Here's a conjugate pair. This is the base, making this the conjugate acid. This is the acid, making this the conjugate base. NH4 plus reacts with water. It gives us NH3 and H3O plus. We have a pair right, I'm sorry, I overdid that. We have a pair right there, and we have a pair right here. Acid, conjugate base, base, conjugate acid. I minus plus H2O. We're going to have HI and OH minus, a pair here and a pair here. Base, conjugate acid, acid, conjugate base. This we could actually have two different reactions. HCO3 minus plus H2O could be giving us H3O plus and CO3 2 minus. Conjugate pair there and there. Or HCO3 minus could be acting as a base, and it could react with H2O and give me H2CO3 and OH minus with a conjugate pair there and a conjugate pair there. Okay? All right, so that was the first homework from this chapter. Hope that went well for you. What I kind of envision is you watching these videos and pausing them when you need time to get caught up. Don't worry about that. That's what I intended. And I am doing them at a pretty decent clip, just so that if you do know what's going on, you can get through them a little bit quicker. All right, well, this is Morgan signing off, and I hope you have had a good lesson.